Welcome to September's KMC Controls Stuck in a Bucket webinar. I am Fritz Wichern. I'm joined today by Greg Salisbury, Michael Rozic, and a special guest, Clifford Milligan, is on the call with us, bringing us his expertise from his new station in life. So today we're going to be talking about a little bit of review of the ASHRAE Guideline 36 standards that actually Clifford covered in April and went into some good detail. We're not going to go into as much detail with it today, but kind of a quick look at it, brief look at kind of how the ASHRAE Standards 90.1, 62.1 tie into the Guideline 36 principles, and then we'll have a few different kind of logic examples of how the trim and the respond and different pieces can tie together there in Control Basic. So, of course, always pay attention to your emails after the webinar. You never know who's going to end up winning the raffle for the famous Yeti KMC Controls Cup, which I assume is what we're giving away. I didn't actually verify. So hopefully that's what you get. If not, you'll get something else cool. All right, so we'll kind of talk through this, Clifford. If you want to jump in at any point, if anything makes sense, but in general, we'll kind of breeze through this. I mean, the Guideline 36 objectives, right? Idea is basically standardization, getting multiple contractors that can bid in a market, so you get more possibilities for sequences of operation and naming conventions. So that Guideline 36 creates a standard for engineers, control contractors, commissioning agents, balancers, building owners to all reference and implement. So the idea being to improve the sustainability of smart buildings by creating consistency in the programming and logic flows. Also, it looks at the efficiency, the high performance sequences to make sure we're maximizing the effectiveness of buildings by leveraging the feedback loop of smart building ecosystems, the central plant, air handlers, zone groups, and then diagnose any common performance faults, the fault detection that ties into all this. So like an economizer that's in fault. Anything else there that I didn't cover you think of, Clifford?
No, I think one of the biggest things in April we talked about, we wanted to make sure that we hit on for everybody here was it is a guideline. It's not a standard in ASHRAE. So as you start going through the guideline, or as you see a project with some sequencing that may reference Guideline 36 or may have some points in there about Guideline 36, it is a guideline. So there's a lot of if and then statements for all you programmers out there. So if the design engineer has a return fan with a economizer cycle, here are a few options for you to choose from a sequence and a standardization standpoint. So there's still a lot of selection process based on the design engineer's intent. So it's not a standard of this is exactly how a VAV should operate. So
yep.
Here we are. I guess it was the next slide.
Yeah.
Sorry. Yeah.
No, you're good.
Yeah.
Yeah. So yeah, and it offers that standardized way to lay out their buildings. So kind of a way to say, hey, here's something we can use. So we'll step through here. Again, sequence options, right? The application engineer is responsible for selecting the best method based on the type of building, application, geography, and so on. Simple things like enthalpy doesn't matter in Phoenix, but makes a big difference in Cleveland or Orlando. So things to pay attention to depending on where you're at. This one, again, next slide here. Clifford kind of touched on that. Right, it's a guideline. It's not scripture, but a good guideline to follow. So we'll step in next to some of the common deployments for the trim and respond. We've got the most common implementation of an open loop supplier temperature reset sequence. This first setup, there's no feedback loop, and the outside air temperature determines your supply air temperature, and the air handler defines the delivery of the zones. Your next kind of conventional setup is a closed loop supply air temp reset, which shows us how to create a feedback loop and allows the zone we want controlled to tell the air handler what to do. Outside air still has an effect on it, but by defining these reset limits, it's not directly controlling the heating or cooling delivered to the space. So, any other notes on that one?
No, I mean, many of these, I think the outside air, return air, any of these conventional old school reset ways is what this is indicating here. So it doesn't have to be outside air. So,
right.
Yeah.
So this next look at it is kind of talking a little bit about the, importance multiplier and then the air handler request. So it's basically, right, using that multiplier to scale the number of requests in the zone. It's typically defined by an engineer or end user or controls contractor. It monitors requests for heating or cooling, the difference between space temp and set point. You can scale a request based on the importance of the multiplier, excuse me, for the corresponding zone. Tell the air handler to raise or lower a discharge air temperature to a specified integer, and then monitor the length of time in a zone is to making a request to scale the importance of that zone. So it's known as the cumulative request hours. So just for a rough example, 2 requests and above, you begin lowering your discharge air temp by 2 degrees for 15 minutes until you're satisfied. So.
Yeah, so the trim to respond common, this is a discharge air temperature reset example. How we deploy this quite often, this is, I would be surprised there's not very many standards out there now or many people out there now that's not deploying some version of this per se, but multi-zone VAV air handler, you're looking at all the space temperature. Typically you get a call from the VAV, which is again defined by the engineer. Usually if it's half a degree above set point, you might get 1 call, or a degree above set point, you might get 2 calls, or you can change that, adjust that. And then those calls all get added up, or space requests, depending on the engineer who writes what guideline 36, it could be space requests, it could be calls. And then you can actually build your trim response logic in your air handler based on those level of calls. So a lot of times you'll say, hey, I'm not going to do anything. Don't do anything until your calls get to 3 or above. And then once you get above 3, then you're going to start responding, which is, hey, I got more than 3 requests. I'm going to start lowering my discharge air set point by half a degree for 15 minutes. Every 15 minutes until those requests drop below 3 again. And then you also have limits in there, obviously, to where you can't drop below a specific value. The important multiplier, again, is if you have critical spaces or whatever the case may be, let's just say they have 2 requests and their important multiplier is 4, then the calls that the requests or calls, whatever it is that they get up to the air handler is actually going to be 8. So playing and adjusting all these in the ASHRAE Guideline 36, all these are variable options, and they get configured and tuned in the field during the commissioning process. So, and we all know that that gets adjusted throughout the year, obviously, because you may commission a job in the wintertime and it's going to have different settings in the summertime. So, but yep.
Yeah. Just a little summary there. Pretty much, I think we covered all these, main bullet points of all that. All righty. So that's that. We'll move on to, a visual representation here of the static pressure side of it. So we looked at the discharge air temp. So we're looking at the air side now. The goal here is to constantly lower the static pressure of the system to create fan energy savings. This is the trim portion of trim and respond, right? What else? The idea, I guess, of being you want to control the static pressure from the air handler, allow the VAVs to adjust their minimum position to save energy. So in that case, I guess you'd be wasting fan energy. So it's more efficient to fully open your VAV actuators and reduce your air handler fan speed to satisfy the zones. And again, requests are submitted to the air handler from each zone. They're scaled by their importance multiplier. The air handler controller pulls those damper positions of all the VAVs and compares them to values indicative of a request for more static air. For static pressure, the system can only trim to a point, though, before the well of static pressure dries up, and then more supply is required from the air handler unit, so it can only go so far. And then the one last piece of this, I guess, is just once there is a call for cooling, increase the static pressure from the air handler until the calls are satisfied. These changes are made gradually, approximately usually 0.1 inches every 15 minutes. And it's adjustable, set up by your designer or engineer. So there's a lot of data flying around. It's important to make sure that you have all your, VAV boxes sending the right data. You're pulling the right data to your air handler. I think maybe one advantage in this case is using IP-based controllers. Get you a little faster response versus MSTP, but all right. So we'll look at VAV discharge air limiting.
Hey, Fritz, can I touch on something on the static pressure reset?
Yeah.
I think we had a comment on it last time, but so I've seen sequences written on the guidelines for both for the request of how you generate the request from the VAV. Do you do it like in the discharge air temperature reset? You would do it how far are you away from set point, cooling demand essentially. On the box, you necessarily wouldn't do it off of box flow demands because hopefully you're maintaining your box flow fairly tight. You could actually generate your what I've typically done quite often is generate the request based on damper position. So if the damper position is greater than 95% open, then it generates a request. If it's lower than 80% open roughly, then the request goes away. So instead of waiting until your box flow set point gets out of range before you start responding, you actually do it off of the demand of the damper first and foremost. So once you get to 95%, you're probably going to start getting more static. So anyway.
Right. Yep. And so I grabbed, some of your slides from April and, obviously for all y'all watching out there, for all the detailed information Clifford's referring to, you can go back and watch the April webinar. It goes into a lot more detail. I was kind of skimming through some of the main points here. And then just a second kind of deployment here of using the VAV discharge air limiting. So, traditionally, right, as cooling demand increases or flow increases to satisfy cooling requirement, min flow to max flow. And in reverse, as the heating demand increase, the VAV actuator position would increase to heating minimum set point, and the heating valve would modulate to satisfy demand. So in Guideline 36, cooling stays the same, but in heating, you have a stage 1, you have a heat minimum where the heating valve modulates to maintain a 20-degree delta between the space temp and the box discharge temp. And then stage 2, increase airflow from that heat minimum to a heat maximum while maintaining the same maximum delta space temp and box discharge air temp. So I covered that. Did I cover that correctly?
Mm-hmm.
All right. Sounds good. So those are the common deployments there. In addition to the Guideline 36, you have a couple other standards that kind of play a key role in optimizing the buildings and your efficiency. The standard in the 90.1 is your energy standard for buildings, except in low-rise residential buildings. But the standard provides, minimum requirements for energy efficiency and building design. So it covers your HVAC systems, lighting, building envelope. So its relationship, though, to Guideline 36 is really focused on that energy efficiency of your HVAC systems. So they kind of work hand in hand and complement each other by, or at least Guideline 36 does for 90.1 to provide advanced operational sequences for those HVAC systems to make sure they're really operating at the highest energy efficiency level possible. Then the ASHRAE Standard 62.1 just covers the amount of fresh air and filtration needed to maintain healthy indoor environments, which is obviously key with COVID-19 and a lot of new standards coming into our systems and across in the U.S. So it's just critical to maintain balancing ventilation efficiency and indoor air quality, so you're not overtaxing your system, but you're getting enough fresh air in the buildings. I think that's the general gist of what I was covering there. So they all kind of work hand in hand there, though. So it's good to pay attention to them. So we got that out of the way. We're going to look at some examples of some control basic programs for the different pieces of the trim and respond set point logic that you see in the Guideline 36 and that section 5.114 is our set point reset logic. Typically works by incrementally adjusting the supply air temperature set point based on the highest zone demand, and then responding by either increasing or decreasing the set point over time. So just a general outline, if the zone with highest demand is cooling, supply air temperature is decreased to meet the cooling demand. If the zone with highest demand is heating, supply air temperature is increased to meet the heating demand. Obviously, if there's no zones with a significant demand, your set point's trimmed back down to a neutral value for energy efficiency. So we've got some examples of the logic here. We are working on building these into some base applications, which hopefully will be releasing, well, I'm not going to say when, but we are getting them worked into the base applications so that they'll be available in your application libraries. But in this example, we're just looking at, adjusting the supply air temperature set point based on zone cooling and heating demands. So in this little snippet from Control Basic, we've got the cooling demand, heating demand. Our variables store the highest cooling and heating demands from the different zones. Our supply air set point, that's obvious, based on demand. Next, we get our trim step. And that defines how much that set point is adjusted in each cycle. Typically, it's 0.5 degrees, or at least that's what we've got on this little blurb. Our trim period, it's our interval in seconds between set point adjustments. We have a demand threshold, and that threshold of zone demand percentage beyond which the system responds by trimming the supply air temp. And then we've got a neutral zone. So it's a dead band or a range in which there's no significant cooling or heating demand present, and the system is just going to sit there and be satisfied. Fairly straightforward. Basically, this program is going to continue to kind of check through all those cooling and heating demands from all the zones, whether they're pulled either from your air handler program going out and running requests and device IDs, or if it's mapped from the VAVs up to a single point in the air handler. A couple different ways to skin the cat there. And then this process just repeats at regular intervals, usually every 5 minutes, just to ensure you have dynamic control of your HVAC system. Obviously, you can add some customization to this, right? Have your supplier temperature minimum, maximum set point limits. You can adjust your trim steps based on what type of system you have. Some may respond better to smaller increments or larger increments. We don't have it shown here, but we do have functions that are get max zone cooling demand or get max zone heating demand. And so that could be replaced again with the logic that just pulls the VAV data. Anything else? I think it fairly covers everything there. So next we look at our system request logic. This is just stating from that section 5.6.8 system requests. You have heating requests, cooling requests. Those are pretty straightforward. Any demand that in a zone that exceeds a defined threshold. Ventilation request. So that's when you don't have a heating or cooling need, but you do need air, or no request. So ventilation's needed, but it just remains idle or off. So again, some assumptions for this. We'll have a heat demand threshold, a cool demand threshold, so that you're not constantly sending points up and down, right? Triggers up and down. So looking at an example of a program for that, again, we store our max or our highest cooling and heating demand from any zone, and our max cooling demand, our max heating demand. Again, those can be attained by separate functions where we get the max zone cooling demand or get max zone heating demand. Our thresholds are predefined values. In this example, I think we're using 15% just to determine whether the system needs to switch into cooling or heating mode. System mode, pretty straightforward, cooling, heating, ventilation. So you know what your system's doing and whether your building's occupied. Then we step down through and we just run into our main logic where we check for the cooling or heating demands, and if they're exceeding the respected thresholds, which then just triggers either the cooling or heating mode. That kind of steps through it. Subroutines trigger to activate cooling, activate heating, or activating ventilation, depending on what mode you're in. Obviously, deactivate system just goes unoccupied, right? Let's see. I think that's it on that one. So one benefit that's nice with a lot of our existing controllers that we have out there in our existing VAV boxes, we have a lot of the binary values already set up and in place in our VAV boxes. So this is just a little blurb out of our back 9001s, where we already have the points set up and ready to be pulled for needing the air handler to start, needing cool supply air, BV2, needing warmer supply air, BV7, or needing higher static pressure, BV3. So those are there and ready, and that's part of what we're working to pull some programs together that will look at those points automatically. for you. And then we'll look at, this is an example of a program for increasing and decreasing duct static. Pretty straightforward, just looking at the number of dampers that are open more or less than thresholds determined in the variables. So like I said, there's a few different ways to kind of skin the cat, and we'll be including some of these different ways as available options. So, and that wraps up what I had for some of those examples there. Do we have any questions that came in while we're talking there? Y'all seen anything in the chat? Forgot to mention at the beginning, if y'all have questions, throw them in the chat. Pretty quiet. Any other thoughts, Clifford or Greg, or anything I missed or misspoke on?
I just think that, you know, a lot of contractors are probably doing parts of this already, so it hopefully will be easy to get to it.
Perfect. Well, as always,
So somebody's typing in the comments if you got a few minutes. So
oh yeah, we got time. I was just gonna say, go out and check out the KMC Controls YouTube channel. All the videos are recorded and posted out there. So any of this information's there. If you ever have topics y'all are interested in seeing us talk about, feel free to add them on the LinkedIn post or shoot me an email. Let's see. Did one come in here? Where's the chat?
Yeah, it looks like they're using loops, probably heating, cooling loops, or air loop to reset static or discharge air. And I think there's multiple ways you can do this or get it accomplished.
yeah, there's before Guideline 36 came out with trim and respond back in, I don't know, mid 2000s or something like that. A lot of people, including myself, would use PID loops to reset, very similar. Use PID loops to reset the supplier temperature and static pressure. I'm sure Greg's probably done the same thing before in the past. And then trim and respond came out, and depending on where you were at, it was getting implemented. So I just switched to using that. So, Greg, have you run across that as well?
Oh yeah, yep. I've used loops and damper positions. I've tried it all over the years. So
yep, it all kind of works the same way.
Yeah,
it accomplishes the same end goal.
Right.
Yep.
Yep.
I think Guideline 36, the trim and respond, eliminates a lot of the issues with the PID loops as far as being able to do the zone multipliers, get rid of the rogue zones as well, which you can't do with the PID loops without going in and actually doing programming changes. So I think that's kind of the advantage of trim and respond versus using loops. Greg, do you have any?
Yeah, I mean, so in the past I've used too, like, not multipliers. Well, it's kind of a multiplier, but I use like a BV value. So I could skip zones. So then it would just get multiplied by a 0 if I had, you know, if I'm saying, oh, I don't want that zone to be in the calculation, I would turn it off. So then it would multiply by a 0 and wouldn't get a call or a, it wouldn't be able to affect the reset, whether it's discharge or static. But I do like the multiplier where you can you can keep one in there, but maybe give it lower weight than other zones. So.
Perfect. All righty. Well, if there's no other questions, no other comments, I think that will wrap it up for today. Appreciate everybody jumping on and joining the call. And we will talk to you all next month.
Thanks, everybody. Thanks for having me.
Thanks, Fritz.
Yep. Thanks for joining.